Question 13. Find the volume of the solid generated by revolving the region bounded by the curve y equals x square and the straight line y equals 2x. Complete revolution about x-axis. Solution. First, let y1 equals x square and let y2 equals 2x. y1 equals x square is the equation of the curve, and y2 equals 2x is the equation of the straight line. First, we will find the points of intersection between the straight line and the curve. Putting y1 equals y2. Putting y1 equals y2. So, x square equals 2x, and then x square minus 2x equals 0. Then x multiply x minus 2 equals 0. Here we can take x as a common factor by factorizing the left hand side by taking out the common factor. So x multiply x minus 2 equals 0. So x equals 0 or x minus 2 equals 0 implies x equals 2. So we have 2 points of intersection at x equals 0 and at x equals 2. Now we will put x equals 1 such that 1 belongs to the interval 0 and 2. So y1 equals 1 square, which equal 1, and y2 of 1 equals 2 multiply 1 equals 2. Here we notice that y2 is greater than y1 in the interval 0 and 2, open interval 0 and 2. So v equals pi multiply the integration of y2 square minus y1 square. If y1 is greater than y2, we write y1 square minus y2 square. But here we have y2 is greater than y1 in this open interval. So when to calculate the volume, we write pi multiply the integration from 0 to 2. It is the limits of the interval, multiply y2 square minus y1 square dx, which equal pi multiply integration from 0 to 2 for x square minus x power 4. Because we have y2 equals 2x, so its square equals 4x square, and y1 here y1 equals x square, so y1 square equals x power 4 dx. The integration is with respect to x because the revolution is about x-axis. So the value of integration, first we write pi, and the integration of 4x square is 4x power 3 over 3. We increase 1 to the power and we divide to the new power. So we have 4x power 3 over 3 minus x power 5 over 5, and the limits of integration from 0 to 2. Now substituting x equals 2, 2 power 3 equals 8 multiply 4 equals 32 over 3. And substituting here x equals 2, so we have 2 power 5 which equals 32. Now we have 32 over 3 minus 32 over 5 multiply pi. 32 over 3 minus 32 over 5 equals 62 over 15 pi cubic unit, and this is the volume of the region bounded by x square and the straight line 2x. Next question is question number 14. If y equals a e power x power b, again if y equals ae power b over x, prove that xy y double dash plus 2y y dash minus x y dash all square equals 0. Now we have y equals a multiply e power b over x. Notice that the power here is variable. The power is b over x. It is variable. So we must take the natural logarithm to both sides. So by taking the natural logarithm to both sides, what we get? Ln y equals ln a multiply e power b over x. So ln y equals, here we have the product of a multiply e power b over x. So ln y equals ln a plus ln e b over x. And then ln y equals ln a plus, here we have the power of e is b over x. We can put it outside the logarithm here. So ln y equals ln a plus b over x ln e, and ln e equals 1. So ln y equals ln a plus b over x. Now we can differentiate both sides with respect to x. What is the differentiation of ln y with respect to x? It will be 1 over y multiply the derivative of y with respect to x multiply dy dx. So the left hand side will be 1 over y dot dy dx dot y dash equals ln a, it is constant, its derivative with respect to x equals 0. Now we have a fractional function b over x, its derivative equals the denominator, it is x, multiply the derivative of numerator, the derivative of b equals 0, minus the numerator, multiply the derivative of denominator, multiply 1 over denominator square, it is equal, it is x square, implies here dy dx denoted by y dash. So y dash equals y multiply this fraction, y multiply right hand side. The right hand side will be negative b over x square. So y dash equals negative b over x square dot y. It is the value of y dash. Now we will get the second derivative, y double dash. Okay, y dash, it is the product of two functions. The first is negative b over x square, and the second is y. The derivative of y is y dash is y double dash. Here we have the product of two functions. So the first multiplies the derivative of second, negative b over x square multiply y dash, plus the second function multiply the derivative of the first. Derivative of negative b over x square is 0 minus negative b multiply 2x over x. So y double dash equals negative b over x square dot y dash plus y multiply this fraction. Simplest form for this fraction equals b equals 2bx over x square dot y here. Now to simplify this relation, we will multiply the two sides with multiply xy. Multiply xy. Why? Because the required here, the required is contain xy double dash, right? Here the required is to prove that xy y double dash plus 2y y dash minus xy dash all square equals 0. Here we have y double dash, so to get this term we must multiply by xy, multiply by xy. Okay, back to full size here. So xy multiply y double dash will be xy y double dash. Xy multiply negative b over x square y dash, it will be negative b over xy y dash. As x here we have x and we have x square, so after you simplify it you will get negative b over x, and y dash we write it plus xy multiply 2b over x power 3y, its result equals 2b over x square y square. Now xy y double dash equals x multiply negative b over x square y dash. Here we multiply up and down by x, so you will get x, it is outside the bracket, and in the denominator we get x square. So we will have x multiply negative b over x square y multiply y dash minus 2 b over x square y dot y, because this value negative b over x square y, negative b over x square y equals y dash itself. So now we can write x negative b over x square y, it is y dash multiply y dash equals y dash all square, it is a part of the required. Negative 2 multiply negative b over x square dot y, negative b over x square dot y equals y dash, it is multiply y. Now we can arrange it to be in the form of the required. Now we have xy y double dash minus we have here positive xy dash square, will bring it to left hand side, will be negative y dash square plus 2y dash multiply y equals 0, and this is the required itself. So after you arrange it you will get here xy y double dash and 2y y dash here plus negative x y dash all square. Okay, you must solve it by yourself to make sure that you understood every step. Here is the required. Now we will go to next question, question 15. In this question here, find the absolute maximum and the absolute minimum value of the function y equals x over 1 plus x square in the interval negative 1 and 2. First, we must calculate y dash. We have y equals x over 1 plus x square. So y dash equals the denominator multiply derivative of numerator. Here the numerator is x, its derivative equals 1. minus the numerator multiplies the derivative of denominator. Derivative of 1 plus x square is 2x all over 1 plus x square, all square. So we have in the denominator 1 plus x square all square. And we'll simplify right hand side. It will be 1 minus x square over 1 plus x square all power 2. It is y dash. So putting y dash equals 0, we will get 1 minus x square over 1 plus x square all square equals 0. It means 1 minus x square equals 0. The numerator equals 0. By factorizing it as a difference of two squares, what we get? 1 minus x multiply 1 plus x. X equals 1 here, or x equals negative 1. 1 minus x equals 0. It means x equals 1. And 1 belongs to the interval, the given interval, negative 1 and 2. Or x plus 1 equals 0. It means x equals negative 1. And the negative 1 also belongs to this interval. Now, there is a critical point when x equals 1 and x equals negative 1. And we find the absolute maximum or minimum at critical points and at the beginning of the interval also, and at the end of interval. So f of negative 1 equals negative 1 over 1 plus negative 1 all square. It means it is equal negative 1 over 2. When x equals 1, here it's a critical point. F of 1 equals 1 over 1 plus 1 square, which equal half. And now we will arrange it. F of 2 equals 0.4. F of 2 equals 2 over 1 plus 2 square, which equal 2 over 5, equals 0.4. So the absolute maximum here is half f of 1, because f of 1 equals 0.5. It's the greatest value here in this interval. In this interval, negative 1 and 2, the greatest value is 0.5, so it is the absolute maximum. And the smallest value, when x equals negative 1, we get f of negative 1 equals negative 1 over 2, so that's why the absolute minimum value is negative 1 over 2. Question 16, using one of the integration methods to find integration of ln x all power 2 dx. First, we'll make this table. We will divide ln x square into two functions, into two parts. Ln x all square, and the second is dx. Now we can easily differentiate ln x all square with respect to x. It will be 2 ln x over x. 2 ln x over x. The differentiation of ln x all square is 2 ln x. Multiply the derivative of ln x, it is 1 over x. So the full result is 2 ln x over x. And the integration of dx, it will be x. Now the result equals, the result of integration equals ln x all square multiply x here minus this product, the product of 2 ln x over x multiply x, which equal 2 ln x dx. Okay, again, I equals ln x all square multiply x minus this product, the product of 2 ln x over x multiply x, which equal 2 ln x dx. And we have another integration here. Now the right hand side will be x multiply ln x all square minus 2 ln x dot dx. The second integration here, it is ln x dx. The integration of ln x dx will make another box of integration here, and we will divide this into two functions. The first is ln x and the second is dx. One of them will differentiate it, it's ln x, and it is easy to make a differentiation to ln x. The result is 1 over x, and the integration of dx is x. It is the same step. So the result equals ln x multiply x minus the integration of x by 1 over x dx. So the right hand side will be x ln x all square, we write it minus 2 here, and the integration of ln x dx equals x ln x minus the integration of 1 over x multiply x equals dx equals 1. So, and the integration with respect to x. Now we have x multiply ln x all square minus 2 multiply x ln x minus the integration of dx is x plus c, and we complete simplify x multiply ln x all square, it is the same, negative 2 multiply x ln x equals negative 2x ln x, negative by negative, it is positive 2x plus c. We can take x as a common factor to simplify or to write the right hand side on its simplest form. We'll take x as a common factor, so we get between bracket ln x all square minus 2 ln x plus 2 plus c, and this is the end of question 16. Now go to next question. Question 17.